Yeah, we're looking at discrete PDFs in this video. So I'm going to give you an example of one. We're rolling a dice. So if we look at this, X could be 1, 2, 3, 4, 5, or 6. I love formatting. 1, 2, 3, 4, 5, or 6. And we've got to think about the probability of each one happening. So because these are equally likely, we say that this is 1 over 6, 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 and 1 over 6. They each have a 1 out of 6 chance of happening. Okay, assuming the dice is fair, of course. Next, we need to check whether this represents a valid probability distribution. So you may or may not remember from continuous variables. So in continuous, we needed two things to be true. So we needed f of x to be greater than 0, sort of for all x values. And we also needed that the integral of f of x from the starting value to the ending value of the distribution equaled 1. These have analogues in discrete, and I'd encourage you to think about maybe what those are before I just tell you and why this is a valid probability distribution. Pause the video if you'd like to try that. Discrete. So Pi is greater than 0 for all probabilities. So Pi are the probabilities. And then the sum of all the probabilities is 1. So basically, rather than an integral, we've got a sum. So let's check each one. So 1/6 is greater than 0. Cool. And all of them are 1/6. And the sum of the probabilities are 1/6, 1/6, 1/6, 1/6, 1/6, and 1/6. All up, that gives you 6/6, or 1. So yes, this is a valid PDF. Now, I want to point out this is actually called a uniform distribution. And what that means is all probabilities are the same. And then if you look at a histogram of this, I think the reason they call it a uniform distribution is because you'd have 1/6 as the probability, and you would notice that all of these bars are like equally high. So it's at a uniform height, so to speak. Some distributions are a little bit more bumpy, but the total probability always has to add up to 1. Find the probability that x is in between 2 and 4. So what this would be is that it's equal to 2, and that it's equal to 3, or that it's equal to 4. So this would be a 6th plus a 6th plus a 6th, and that could simplify down to a half. That's the probability. Now, when we did continuous variables, it didn't matter whether we had these signs or these signs, but it actually does now matter for discrete. So a probability that we're in between 2 and 4, but not including 2 and 4. So this would just be the probability that x is 3. Or in other words, that's 1 out of 6. I also want to point out some notation. Make sure that this x here is lowercase, and then this x is uppercase, and then lowercase again. The notation is super duper confusing, but this is just like one possibility for the big X, and then X is like, we call it a random variable for the dice roll. Personally, I reckon they should use a different letter maybe than lowercase x, but this is sort of the standard. This is how it works. So just be aware of that notation there. And then you could read this off here, probability that big X equals little x. You'd read this as probability that big X, whatever the dice rolled, equals, and little x in this case is 1. So that's how you'd read off the table there. Okay. Next, we've got 3 coins, and we're going to count the number of heads, construct a table, and check that it's a PDF. So easiest way to do this, and we'll be doing this a lot in this topic, is tree diagrams. So this is going to be flip 1, and then I'm going to go flip 2, and then I'm going to go flip 3. So you get heads or tails. You can get heads or tails there. Heads or tails. Heads or tails. Heads or tails. Heads or tails. Now, it's pretty easy to work out the probability along each branch because each probability is 1 out of 8. I should make sure those are actually aligned with the flips. There we go. 2. Let's call it F2. Basically, all the probabilities here are an eighth. But the way that you get that is you can sort of label each branch. So you got half chance of head, half chance of tail each time. And this method's going to be really useful for if, you know, it was a rigged coin and you had 3/4 chance head, for example. And so I guess what we would say here is that the probability of head equals a half times a half times a half, which is 1 out of 8. Now, all these probabilities are just all going to be 1 out of 8. And then we can sort of look at what each one is. So this one here we already discussed was sort of like head, head, head. This one you can read off the branches. So you go up, up, down. So head, head, tail. And you can sort of map out each one. Head, tail, head. Head, tail, tail. What have we got? Tail, head, head. Tail, head, tail. Tail, tail, head. And tail, tail, tail. Okay. So then we also need to count, I guess, the number of heads. So I might just move this probability calc over here. So we're doing that. And if we look at number of heads, here we had 3 for that one. Then we've got 2 for that one. We still got 2 for the next one. Then we got 1 head there. We got 2 heads there. We got 1 head there, 1 head there, and 0 heads there. So pretty much if you look at, let's do it in a table. So we're going to have x and probability that x equals x. And I might just say let x be the number of heads. We can see that we're going to get 0, 1, 2, or 3 heads. Those are the possibilities. The 0 and the 3 are easy enough to fill out. So there's only one way that you can get 0 heads. So you get 1 out of 8. And there's only one way that you can get 3 heads. So that's 1 out of 8. But if we look at 1 head, you've got 1, 2, 3 ways to do it. So this, what I would put in here is the 8th, the 8th, and the 8th. So that's for each possibility. So that would be like the head, tail, tail one. That would be the tail, head, tail one. And that would be the tail, tail, head one. And then you get 3/8 for this one. And then the last one does end up being 3/8 as well when you do it. There's 3 lots of the 2 heads. They each have a probability of an 8th. So is a PDF. So all the probabilities are greater than 0. Yes, it is. And the sum of the probabilities, this would be an 8th plus 3/8 plus 3/8 plus an 8th, which does equal 1. Yep, so it's a PDF.